Hi guys, this is a video that I wanted to do for a while, and this is basically meant to be a little bit of deep dive inside MetaHumans. The reason being, MetaHuman it's an amazing tool from Epic Games, and I saw a lot of people using it right now. But when with myself still learning Unreal Engine, I never I saw people using it but never really understood everything about it, like the way it's assembled and the way the structure is. And rather than simply using it as a tool, I wanted to try and spend some time to actually understand what's going on, because it's quite simple to use, but it's complex and beautiful in its execution. So I spent a lot of time going through MetaHumans, and what I'm going to do in this video is basically following the notes some notes I've made. I think I'm going to make this PDF available, and you can decide to download it or not. But so I'm going to try to go through a little bit in detail. And please, by no means this is meant to be an expert opinion, because I'm not. So if I'm making any mistakes along the way, please correct me. Let's start. So the first thing I want to talk about is the folder structure. So once you export your I'm not going to go through how to get MetaHumans. It's through Bridge. There are hundreds of videos and tutorials about it. The first thing let me hide the source engine content and the plugins content. So the first thing I want to talk about is the folder structure, and the folder structure, it's really simple. When you open the project, there is a folder called MetaHumans, and then you're presented with two things. The first one, it's common, which actually contains the true core and complexity of MetaHumans. It's all the core and the shared assets. And the second folder is the MetaHuman specific, let's say, asset instances of the specific MetaHuman that you have built through MetaHuman Creator. In this case, is my name. Basically, this folder contains the specific asset for this specific MetaHuman. To give you an example, there is material instances, there is texture instances, and there is the but there is no skeletons in here, and the same goes for source materials. Everything inside here can be considered an instance of what is actually inside common. There is the naming convention. It doesn't follow precisely the naming convention suggested by Epic Games themselves, but overall you have blueprint underscore with BP underscore, MI for material instances, and M for material. Skeletal meshes, animation, static meshes, and textures do not follow. Let me filter through animation clip, animation sequence. They don't have a specific naming convention. I mean, it's a naming convention that makes perfect sense. That's what I'm saying. But if I looked up online, it doesn't follow the standard naming convention. I don't know, that's a choice. If that's a choice, maybe it is. The naming convention per se makes perfect sense. I know that there is a way to offset the naming convention of certain assets through Bridge. I never done that, to be honest. So maybe I'm completely and 100% wrong here. So let's start with the first thing that you're presented with in this folder is basically, it's where everything starts. It's the blueprint of the character. Let's open it. The blueprint of the character is it has, the first thing you have, it's a body, and it's a body skeletal mesh. If I browse to this asset, immediately you can see that I'm still inside the folder of the instance, and if I double click on it, the body is actually purely hands and the little bit of the legs that you see below. And the reason is everything else is basically driven by the skeleton. What I was mentioning before is that if I check where is the skeleton for this skeletal mesh, the skeleton itself, which is this one here, if I browse to it, you can see that it is under common. Actually, is under common female. So what I mean is that everything that is common and shared among metahumans, control rig, etc., exists under common. So it makes perfect sense. I'm not going to repeat myself too much. If we go back into the blueprint, we can see that there is a body that is basically the driver of everything. I'm going to explain that in a minute what that means. Then we have the face skeletal mesh, which again it sits under this folder. Please ignore these assets here are generated by a tool that I am working on. You can see other videos about it. Please ignore these assets. These assets won't be there. But this is the skeletal mesh for the face, and if you look at it, it's basically the skeleton up to the spine. So there are all the face joints and around the shoulder area and the chest and the upper chest area, and then it goes up to I believe being spine 4. And the reason is the body drives those joints up to the neck area. Underneath here we have the groom. The groom is separated in different portions, which makes perfect sense. Hair, eyebrows, fuzz, eyelashes, mustaches, and beard. This is basically the groom that it's generated by MetaHuman Creator. There is no current, I don't think there is a way. If I browse to this folder, you can see that the groom is specifically designed under my instance of the character, but you cannot export this as an alembic. This exists as a groom entity. Each groom, of course, has a binding, and it sits inside groom binding, and this groom binding is assigned specifically to the face mesh. So it's a standard groom setup for Unreal Engine. And then at the very end we have other skeletal meshes, which happens to be the torso and the legs and the feet. And all of these are driven by the master input pose. We'll see that in a minute in the graph. At the very end, there's a really cool note that I actually didn't know about, so I learned this on the way. It's a lot sync, and basically there are 11 components in total, with body and face as drivers, and everything else is passive, which means that when some kind of operation along the way in the engine triggers a lot change in the body, everything else comes through, which is really nice. So the body is the main body use the animation mode is set to animation asset, which makes perfect sense. But the face, this is where live linking and everything that it's related to the face, real time. The face instead is set to an animation blueprint, which we're going to talk about it later, is face animation blueprint. And you can see that this face animation blueprint actually sits under common, which means this animation blueprint can be shared among, it's meant to be, the source asset for pretty much every metahuman out there. One thing, and then all the other skeletal mesh is set to animation blueprint mode, but with none. And I bet this has to do with the way, if you want to quickly animate these in sequencer. So another thing I wanted to check is, which wasn't really clear to me, and thanks to MetaHuman it became more clear, is the scenario about it's everything that is related to the skeletons and the physical assets. I was never sure how easy it was to have different skeletons connected together with different office joints. And the other thing I wasn't sure about is how to build specifically physical assets that work in conjunction very well together with the groom, because I had rendering issues before if the physical asset was not tweaked correctly. So let's jump into the body skeletal mesh. The skeleton for the body skeletal mesh is this one, is the base skeleton. Basically it's the whole thing without the face, and this is the main driver, as we said. If we open the skeletal mesh and we look through the physical asset is exactly what you expect, meaning that it's very fine-tuned around the cage, around the mesh, and following the structure of the skeleton. One thing that I didn't know because of my ignorance in Unreal Engine was that if this physical asset was meant to be associated as well with another mesh that shared the same skeleton, or a mesh that it's meant to be attached to it, but it's absolutely not. If we go into the face, for example, and we go into the physical asset, you can see that each individual component, skeletal mesh component here, has a specific physical asset specifically designed for that. And this is what it clarified in my mind, how things work basically here. Because one thing that I realized is that physical assets in Unreal are really important to draw the depth, to properly interpret the depth. And this is true for Groom as well. So the body has the standard skeleton and it has a custom physical asset, and is basically the master driver. The face has a custom skeleton and it has a custom physical asset. The hoodie per se, so the upper hoodie, which is in this case is the torso, has a different skeleton altogether. And the reason probably is because the skeleton has, let me see the bones, the skeleton has additional joints to deal with additional deformation. For example, if I remember correctly, the strings around here. Again, this is a skeleton that is mostly identical to the body, but on top of it there is additional joints to move the additional portion of the geometry. This is something, I'm a rigger, I'm a Maya rigger, former Maya rigger, and this is really interesting. It's really similar on how you would build a very complex creature with costumes and variation of costumes, but being in real time, they come up with loads of nodes that allow you to connect skeletons together really quickly, something that in Maya can become very, very, very slow to pass transform data among skeletons. So the legs and the feet, they do share the same skeleton with the body, so it's a standard skeleton, but each one of them has a custom physical asset. Let's see, for example, the feet. The feet, if I jump into the physical asset, it has a custom thing. You see, I never knew that we could, it was really important to have custom physical asset per skeletal mesh component, and the reason is, I always thought that it was better to share physical asset as much as possible, but actually this makes things a little bit more clear and precise and clean. Now, the next thing to have a look at is the construction script of the blueprint, and you can see here that basically we have this function here that does some checks. It says, okay, so is the skeletal mesh is valid, and basically make the body the master component of that skeletal mesh. I usually do that here, but there is a specific function that takes care of doing the check-in. But basically this graph says make the feet move like the skeleton of the body, make the legs move like the skeleton of the body, make the torso move like the skeleton of the body. And then there is a nice comment here that says, okay, create a material instance on the face, turn the eyelashes material into mid, so we can toggle opacity when using haircuts. This is basically an optimization thing. So when it comes to the material of the eyelashes that is applied on the face, rather than using the one specified in the skeletal mesh, is creating a material instance. It's probably because down the line we're going to try to at runtime to change material properties. So the construction script is very, very simple. Let's jump into the event graph. Now the event graph starts with we have only the event begin play. Let me open this one here. We went through the construction script. This is the function that enabled the master pose. Now we're talking about the event graph. The first thing to notice is that there are two variables. One variable of type live-link subject and one Boolean variable. And we'll see what that goes. So in the event begin play, it's running a command variable, and basically here's where I think we're doing the eyelashes bit that I was talking about before. If somehow the groom is enabled or disabled, we're switching properties of the material of the eyelashes. Yeah, we're basically, if this happens to be false, then we're changing the parameter value of basically the opacity RT, which I think stands for the real time. So it's basically all this is doing is taking care of the eyelashes. So the event begin play, really, if we remove all of this, it's literally connected to the ARKit setup, which is another function. If we look into it, finally I think we're going to get use of these two variables. We get an anim instance of the face skeletal mesh. We cast it to check. We cast it as a face animation blueprint, and then we say, okay, this variable represents nothing else than your device where you're streaming your face capture, and this is 99% of the time the iPhone or the iPad with a true depth camera in front. So there is a free app on the store that allows you to capture your face and stream that face data, blend shape weight, directly inside Unreal. And this is basically, here is where you would specify the target hardware. So, and this is just a boolean to say I want the live link to happen or not, and these two are exposed, and because these are exposed, there they are in the main blueprint group node, sorry, instance in the viewport. So again, this is nothing else to say. Both the construction script and the event begin play, sorry, and the event graph are fairly simple, which makes me really happy because I'm still learning. So let's talk a little bit about the Groom. So the Groom, basically the Groom has most of the Groom assets. I was really curious because I experimented a lot with the materials for Groom, and this happens to be a one-to-one match with the Being MetaHuman Creator. I suspect being completely Unreal package. This is the exactly same material that comes from a MetaHuman Creator. Every Groom asset inside the specific MetaHuman folder, it's a material instance. If we open this material instance, it has all sort of parameters to change, and these happens to be the same exact parameters that are in the MetaHuman Creator, maybe with a slightly different naming convention, but that's pretty much it. Let me just try and see if I get this one and I change this material instance. Well, actually I have it in the viewport, so if I change the material instance, I can go and change the parameter of the white amount, for example. You can see it changing here. So what is happening is that each Groom, basically, there is an exception, but each Groom has assigned a material instance, and this material instance is actually coming from a master material, and this is the one that I was really interested in because this is where all the complexity and variation comes through. It starts with the hair attribute, so we can read values of the U and V value of the curves that generates the material, the group, and then there is all sorts of multiplication and an interpolation between color and values. And this graph, it's worth having a look. I'm not going to go through it, but it's an isolated, very simple little bit of graphs, but put them together, it gives you a nice variation, complexity on the group per se. And what I found is that there is one exception. So basically, all the Groom asset have this material as an instance. so sorry, all the assets have material instances, and all these material instances are coming from this material, which happens to be material V2, and as you may expect, is under common, because source materials sits under common and shared assets, which makes 100% sense. There is only one exception, and that exception is the fuzz. The fuzz, which is, you know, the fuzz fur or hair that you have on your skin. For shading reasons, probably this fuzz shader has a completely different material. So still is a Groom asset. You can see it here. You can see it's Groom binding, but the material is completely different. The material is called peach fuzz, and it comes from a material instance per se. And then if we traverse back into the graph, we finally found another master material, which happens to be peach fuzz master. And this material, I believe it's meant to give a specific shading to represent that specific effect that we're trying to achieve. The material type is a surface masked, and the shading model is defined from a material expression, while instead here, if we go into the attributes, where is it? The attributes of the shader, yes, it's basically the shading models. It's basically hair, so it's two different shading models. Okay, so this is okay for the Groom, and then if we go into the next thing I want to talk about is the eyes, which is another amazing thing. The eyes, of course, are geometries that are embedded within the skeletal mesh of the face. So face, everything when you import it into Unreal is all merged together. And the eyes, the complexity of the eyes is all through shading, which is awesome. There is a left eye shader and an eye right shader. So the two shaders are two different material instances, but they all come from, and there is all sort of attributes here that allow you to change. And this happens to be the same attributes as you can expect from a MetaHuman creator, and they all come from a master material, which happens to be this one. And again, loads and loads of things. And one thing I've noticed that they all come from the same master material. And one thing I found is that basically 80-90% of this shader is completely procedural, meaning that, for example, the roundness and the ramp of the eye, of the iris, is all generated by procedural maps. If we have a look at the shader per se, there are masks or maps that you can input, but a lot of this shape is achieved procedurally, which is nice because it means that the shader can be adapted to a lot of scenarios. So the conclusion for this first bit is that overall the blueprint character MetaHuman is not that complex, fortunately, and it's beautiful that way. And the complexity comes afterwards with the animation blueprint, the pose assets, and the control rig. So so this is one thing I found that I found really helpful to do. So if we keep going with the shader side, I forgot about talk about the skin shader. The parent material for this shader is quite complex and implements surface scattering. The shader again, it's a one-to-one mapping with what you have in MetaHuman Creator, and it comes from a material that is called m_head. And again, this sits under common. What I found interesting is that basically it's the way it's assembled is that it provides you with all sort of layers to do things and on top of one another. So you have a specific graph to implement the lipstick color and saturation, eye makeup, freckles. All you can see that this is really nice commented, and there is a section of the graph that is called artist delights, meaning that you can offset a lot of stuff on top of the standard skin shader. You can add and remove freckles, but in here you can say, you know, you can have redness, saturation, you know, and stuff like that. And these are exactly the same parameters that you can play with in the MetaHuman creator. So this material probably it's a one-to-one. And then I found there is a lot of interesting stuff that I actually still have to learn. And this kind of node here allows you to specify a different portion of the graph if it's the default standard client that you're working for example a PC. But then if you want to implement MetaHuman on mobile, then you can switch between different portion of the graph. For example, the metallic, it's because mobile, not all of them implement deferred rendering. The metalness is implemented completely different, or stuff like that. In this case it was roughness, but you know what I mean. Basically the portion of the graph can be simplified quite a lot. Yeah, so the cool thing about the shader per se, it's using a subsurface profile, so a surface opaque. Of course, the shading model is subsurface profile, and the subsurface profile is nothing else than a node. It's an attribute node that gives you starting default attributes for that specific shader. And the cool thing about, and there is an option to blend the final color into the clay material. So instead of having the color, you get a nice shade of gray. Sorry, I'm looking through the notes. I just want to make sure. Oh, there are really interesting material functions in here, and one is the animated map, and the other one is the baked Groom textures. Baked Groom textures, I still need to understand exactly what it does, but I think it does exactly what I think it does, meaning that it allows you to display or not display a pre-baked group textures. That's what I think it does. I haven't went through this graph yet, which is something I want to do. And the other nice material function, if I can find it, is this one. This is really interesting to me. This basically allows you to specify mask and trigger masks on and off for blood flow maps, or having the wrinkles normal map being triggered in a specific area when a specific blend weight attribute comes through, either from sequence animation or live link. And then another interesting thing I found is that there is a neck map that allows you to fade basically the neck area somewhere in here. Basically, I'm not going to go through it all of it, but it allows you to fade the base of the neck, probably to hide certain portion of the seams, etc. And then yes, another thing that all of you guys know, because you're more expert than me, is just that everything that is related to subsurface in this specific shader model goes into the opacity. So if you follow back the graph of the opacity, it gives you everything that is related. Oh, there it is. I was looking for this. It gives you whatever portion of graph deals with subsurface. Okay, so another. Oh, let's keep going with the shaders. I found that this is another interesting one. Everything that is cloth related comes from a fabric simple fuzz shader, and this is something, again, I haven't looked through properly. It's a surface opaque and a default lit shader. It has nothing to do with translucency. And one thing I found really interesting is that it does make use of world position offset. So there's probably some kind of displacement happening in there. And one cool thing as well, like similar to the other graphs, is that it gives you a layered approach, and there is stitching, pilling, and all the garments. You can layer these things on top. And I don't know if I don't remember, to be honest, if these options are available in the MetaHuman creator when it comes to clothing, but this shader definitely has that implemented in the graph. Another thing I want to talk about is the textures. If we go inside the face, the textures are 2K in resolution. They have 12 number of bitmaps, so it's a pretty much standard texture. Most of them are sRGB, 2K resolution, 12 bitmaps. They're of course square. They're power of 2. That's what I mean. And one thing I've noticed is that the texture group sits under character, which means I need to investigate exactly what this kind of loading mechanism, what kind of option this gives us. So I'm going to have to have a look at that. The costume textures are a bit more procedural, meaning that the color is an attribute, and the attribute is multiplied by a mask, and then this allows you to change, for example, the color of the hoodie, but preserving all the masking, like all the wrinkles and all the stitching and stuff like that. So everything that you do in MetaHuman Creator can of course be offsetted inside actually Unreal. So my conclusion about this is just the materials are really complex but powerful and very, very well documented, so kudos to Epic once again. And textures are pretty straightforward. They are complex themselves, but there is nothing in there that I could find that it's different from any other project that I've seen in Unreal. Let's stop the video here for now. I want to dedicate a specific video for the face animation blueprint and the body blueprint.